Chapter 9 now continues with flow problems. 9C flow problems. Question will be, can you use concepts of maximum flow through a network or the minimum cut on a network to solve problems of flow through a network? Consider the following diagram. We've got two pipes connected on a system. It could be water or gas or anything. 25 litres a minute capacity on the left hand side and a 58 litres per minute capacity on the right hand side. What is the maximum flow through this pipe? The answer has to be the smallest number, 25 litres per minute. Doesn't matter what the other side can do, it's only getting 25, it's only ever going to do 25. What about this one? 58 in, 25 continuing, exactly the same thing. It is the minimum capacity which determines the maximum flow. If pipes of different capacities are connected one after the other, the maximum flow through the pipes is equal to the minimum capacity of the individual pipes. Now, we're not just talking about gas and water, we're also talking about things like, this could be cars flowing between cities A, B, C, D and E. The capacity is therefore the capacity of the road, 300 cars an hour, whatever, between towns A and B, 600 cars an hour between towns B and C. Now, somebody travelling from A to E could go via B, C, or could go via D. The capacity of the road network via BC is going to be whatever the smallest number is. So 300, 600 or 800, it doesn't matter what capacity there is on BC or CD, there's only ever going to be 300 cars going through there. Likewise, if you go via D, the capacity is 150. So that's the basic concept of maximum flow. To get technical, we need to talk about where the flow starts and where it finishes. So we call the beginning the source and the end the sink. Source and sink. And then we have to introduce the concept of a minimum cut, by which we mean, on say the diagram here, we have got alternative ways of getting from the source to the sink, in other words from S to T, and in order to find out what the maximum flow of this network is in general, is we have to do some things called cuts. And then we find which is the smallest cut, that'll be the minimum cut, and that'll be the maximum flow. Now there is one way to cut the pipe. If you cut the pipes at SA and SC, nothing will get through the network. That's why it's called a cut. So you've got to cut the network completely in a variety of different ways in order to find out what the maximum flow is. So calling this cut 1, we have cut at 8 and we have cut at 11, so that produces a cut of 19. And what we're going to try and do is find a smaller cut, which will be a way of determining what the maximum flow is. Here's cut 2. Now, you might think that it is 11 plus 3 plus 5, because we go through 11 and a 5 and a 3. But where's that 5 coming from? Now that 5 is only coming from CB. That 5 has only got a flow of 3 going in there in the first place, and in turn that 3 is coming from that 11. Well, if we counted AB, we'd be counting CB twice. That 3 there is the same as that 3 there, so that's why this cut is only 11 plus 3 is. This one is a problematic one, C3. I reckon that we only count 11 and 3 is 14. Obviously we're not going to count that 3 there, but the textbook counts that 5, and I'm not quite sure why. Anyway, it's still not going to be the minimum cut, so it's not really material. This is C4 in the textbook. We're going to count the 8, and we're going to count the 3, and we're going to count the 1, which is cuts there, and there, gives you 12. C5, 3 plus 3 plus 1, we're going to count that 3 there. We're going to count that 3 there, and we're going to count that 1 there. because it doesn't matter whether there's 11 going in, we're only going to have 4 coming out of C, so that's 3 plus 1. BA won't count, so that means we just count AT, and that is 7, not 12. C6, more straightforward, 3 plus 5 plus 1 is 9. There are the 6 cuts, with the provision that I don't agree with their C3. So the maximum flow of this network is where the minimum cut is, which is 7. Here's another example. Cuts are already on there, some of them anyway. The capacity of C2 has been given, and pointing out that this one is 4 plus 5, both going in towards E. We can't count anything coming out of E because we've counted everything going into E, but we do count the 3 up there, which is gone via B, so 12. Just another example of where you don't count some of the numbers. Now, we've got an alternative method which is a bit dodgy as well. Quick matter here: if there are 2 sources and 2 sinks, you treat them separately. This 200, which is going from source 1 network to network 2, gets included in Dunlop South because it's going into Dunlop South. Good. I'm sure you can now solve maximum flow problems by finding minimum cuts, and exercise 9C has got plenty of examples for you to practice.